Hello everyone, and welcome to the mini test solutions. First problem we had was to use substitution method to solve 3x plus 2y is 14 and y is x minus 1. So for the substitution, we already have the second equation solved in a way that dy is isolated. So we can go ahead and paste it into the first equation, which gives us 3x plus 2 times the value of the y, which is x minus 1, end of bracket, which equals to 14. Now we break apart the brackets, we multiply each term inside them by 2, and we get 3x plus 2x minus 2 is 14. Now we move numbers to the right, combine x's on the left, we get 5x is 16, which gives us x is 16 fifths. We move that to the side and insert this into the second equation so we can solve for y. Y is 16 fifths minus 1, which is 11 fifths, so you just take 5 away from 16, and these are the two results. Hopefully there were no complications on this one, because it was quite easy. Problem number 2 was to be solved by elimination, and we already have the y terms, one negative, one positive, so we can just add these two together, which gives us 6x equals 12. Divide by 6, x is 2, we keep y on the left, we subtract 2x on both sides, we get y is 3 minus 2x, 2 times 2 is 4, so 3 minus 4 is minus 1, the solution is x is 2 and y is minus 1. Now we have a system with fraction coefficients. Now this isn't in any way harder than other systems, the coefficients are just fractions, so instead of having to multiply by 2 to get 2x and 2y, elimination method of course, here we just multiply to get a whole number, so we don't have the fraction in front of it. So we have y, which I think is the easiest one to do here. One is positive and the other one is negative, and the negative one is 1/3 of y. So we just multiply the second equation with 3. We get 3x minus y is 3. We add these two together, and we get this. I already took liberty of writing 3 as a fraction of halves, so it's 6 halves. And I add these two together, we get 7 halves times x is 7. Now, when we divide with 7 halves, we get a double fraction. We can write 7 as 7 wholes, 7 divided by 1, which is divided by 7 divided by 2. And by the cross rule, we combine the center two center two numbers under the line of division, and the outer two above the division line. So 7 from 7 wholes stays above and is joined by the 2 from the 7 halves, and the rest is under, like so. So the inner are combined under the division line and the outer are combined above the division line. So this 2 moves up, this 7 moves up, and we get this. Now we can cancel out the 7s because it's division, and we get 2. So x is 2. Now we plug x in the second equation by moving y to the right and 3 to the left, and then just mirroring it, so we get 3x minus 3 is y is 3x minus 3, and then we insert x as 2, we get 6 minus 3, 6 minus 3 is 3, so y is 3, x is 2, y is 3, that is the solution. Now for the 3 variable system, I just changed them up a bit. The first equation is x plus y plus z is 6. The second one is 2x minus y plus z is 5. Third one is x plus 2y minus z is 3. So first I'll add the first and third together so I can cancel out the z's and solve for x, for instance, or y. I'll see up later. I combine the first and the third, we get 2x plus 3y is 9. Now I see one step ahead, so I'm gonna isolate y, because if I divide 9 by 3 I get a whole number, I don't have a fraction, so I simplify the process of solving. So I carry it over to the right, divide by 3, and we get a simple result for y. Well, simple of sorts. Now that we have y that is only comprised of x, if we find 2 equations in which z is cancelled, and that we haven't used before, of course, so we can't use the first and the third one again to use it for the y, because we will get 0 equals 0. So we find the other 2 equations and just cancel out the z and plug the y in, so we have only x's in the entire equation, and we can solve for x. So I choose the second and the third equation, where z cancels out, and I can plug in the expression for y and solve for x, as I explained. So I add them together, we get 3x plus y, because there's minus y here. We get 8. Now we put in the value of the y, we break the brackets. Now we move the y out of the way, so we can just solve this down. I will take 3 to the right, so we get 5. And I also wrote 5 as a fraction, so it's easier to do math later. And I keep the x's on the left, so I combine like terms. So x outside the bracket, and whatever is left, so it's 3 minus 2/3, which is 9/3 minus 2/3. We get 7/3 on the left and 15/3 on the right. We do the double division, or whatever this rule, crisscross you call it, and we carry the 7 up and the 3 up, but now we see there's a 3 in each level of the line, so we can cancel it out. So if there's one under the division line and one above it, like so, we can just cancel them out, and we are left with 15/7. So this is the result of x. We move it to the right with the results. Now we plug it back into the equation for y. We get this type of multiplication. We multiply 2 and 15 and 3 and 7, but we can also cancel out 3, because 15 can be written as 5 times 3. So we cancel out the 3's. We are left with 5 times 2 on top and 7 under. So 3 is 21/7. 21 divided by 7. And 2 times 5 divided by 7 is 10/7, however you pronounce it. So when we take this apart, we get 11 divided by 7. Now we plug both of them into one of the equations. I'll choose equation number 1 and solve for z. So 6 in fraction writing is 42 divided by 7 for this example, because everything is divided by 7 here. I take away 15 and I take away 11. So it's essentially 42 minus 26, all divided by 7, which is 16 divided by 7. And these are the 3 results. Hopefully this wasn't problematic, and that we can move on without having to think much more, because we know how to solve these problems now. Now, a word-based equation system. A small store sells pens and notebooks. A pen costs 1.20 euros, and a notebook costs 2.5 euros. Student 1 buys 5 items and pays 8.6 euros. Student 2 buys 11 items and pays 18.4 euros. We also know that student 2 bought 2 times more notebooks than student 1. Find how many pens and notebooks each student bought. So I took liberty to mark what is somewhat important, and I will use the screenshot of this text to use instead of the title, so we have as much space to solve it under, and we can always return back for the values. So I assigned that the value of 1.2 is equal to P, which stands for pens, and N stands for notebooks, which has a value of 2.5. I assigned the value of S1 for student 1 as 8.6, which is the amount of money he spent, and student 2 S2 is 18.4, because that's how much money he spent. Now let's first see what equation or equations we can write for student number 1. So student number 1 bought A times pens, so number A of pens, let's say like 5 pens is A pens, and B notebooks. And we know that he bought 5 items, so A plus B must equal to 5. And now we have 2 equations with 2 variables, which are A and B, because S1 is a certain value how much money he spent, P is the value of the pen, and N is the value of the notebook. So let's take A from this equation, and we get A is 5 minus B. Now let's color all the variables with orange, so it's easy to keep track, and we insert this expression instead of A. So 8.6 as S1 is A, or 5 minus B, times the value of a pen, which is 1.2, plus B, the number of notebooks, times the value of a notebook. Now we multiply each of the terms with the 1.2, we get 6 minus 1.2b plus 2.5b. We move 6 to the left, we get 2 times 6, and on the right we add minus 1.2b to 2.5b, which is 1.3b. We divide by 1.3 on both sides, and we get b is 2. Now we can put the B value inside here so we can calculate how many pens we bought, because B is the notebook number, and 5 minus 2 is 3, so we have 3 pens and 2 notebooks. Now we solve the same way for student number 2, where we have an even easier situation. Why? Because we know that the red text, as I marked here, shows that student number 2 bought 2 times more books or notebooks that the student 1 bought. So since we know that student 1 bought 2 books, this means that 2 times 2 is 4, so we know that student 2 bought 4 notebooks. And now we have only one variable left. And either we solve it by using this equation, or we just say 11 minus 4 is 7. Whichever way you did is correct. I'm gonna take the long way because if you got stuck on this process, it's easier to check out the results and just compare where you got stuck. So either you did 11 minus 4 is 7, or you did the long way like I will. So I insert the values. S2 is 18.4, P is 1.2, and N is 2.5. So we have X here. We move 4 times 2.5 to the left, which is 10. So 18.4 minus 10 is X times 1.2. We are left with 8.4 equals 1.2 times X. If you divide that, you get 7, as 1 times 7 is 7, and 0.2 times 7 is 1.4. If you add these two together, you get 8.4. So, what does this mean? Student 1 bought 3 pens and 2 notebooks, and student 2 bought 7 pens and 4 notebooks. This is the result, which probably the teachers wanted to get. And this is the end of the mini quiz. It was a bit shorter than usual, it was a bit more simple, and the overall lesson was shorter just because there wasn't much to cover, and because it's a simple topic, relatively. We already know most of the basics, we just combined what we learned and used it in a new way. But thank you so much for tuning in to the solutions. Hopefully everything went okay. If it didn't, I truly hope that you can find where you went wrong and you can learn from the mistakes so you don't repeat it on your tests. Thank you so much, and see you on our next video. Bye!